Hi guys, thanks for tuning in. Thanks for your views and your positive comments of support. And I just want to say hello to those that are watching from all over Australia, and hello to those that are viewing from all over the world. Great, thank you for having me part of your family. It's greatly appreciated. And thanks for those that subscribe and continue to subscribe and press the like button. That's fantastic. Today we're going to be looking at surface area and net diagram. We had a look last week on volume, and we spoke about surface area. What I've got on the board here is a three-dimensional drawing of a rectangular prism, and we say rectangular prism because the base, I've highlighted the base like so, just to show you that it is a rectangular base, and therefore it is a rectangular prism. I've put some dimensions. Our length is 6 meters, our width is 2 meters, and our height is 4 meters. What I wanted to do was just to access some prior knowledge of our previous lesson when we spoke about cross-sectional area, area. We spoke about where we'd actually cut this object, if you like, through the prism, and that would be the cross-sectional area. Just as an example, just trying to write it, trying to draw it so it looks as clear as possible to you. That's like the cross-sectional area. It's almost like we're cutting it through, or like we're cutting a piece of cheese or a cake, or whatever the case may be, but slicing it through. And what we also noted was that in this instance, this is as I said, this is a rectangular prism. Now we can say that the volume is equal to the length times the width times the height. That will give us our volume. In other words, our length is 6 meters times our width of 2 meters times our height of 4 meters. And again, we know that the units are all in meters, so we are working in meters. And we know that 6 by 2 is 24. My correction, 6 by 2 is 12 meters, and then times 4 is 48 meters cubed. Okay, my apologies for that, 48 meters cubed. So it's really, really important that this is one way of working out volume. So length by width by height, 6 meters, length times the width of 2 meters times the height of 4 meters. 6 times 2 is 12, times 4 meters is 48 meters squared. But the other way we spoke about was also using the cross-sectional area. So volume is equal to, if we call the cross-sectional area the base, if you want, the area of the base times the height. And if we say the base is equal to our length times our width, okay, which is the same as saying 2 meters, oh, my apologies, same as saying 6 meters by 2 meters, okay, which is equal to 12 meters squared. So we can actually say that our volume is equal to the cross-sectional area times the height. This is another way of working it out. We did touch on this last week, but I just wanted to bring this to your attention more so, because if you were to sit a year 7 or a year 9 NAPLAN exam, you'll find that the process would be, well, the typical way the question would be worded, it would be asked to, you'll have a typical question like this, and they'll ask you to find the volume, and then you'll find the cross-sectional area of the rectangular prism, and then you'll simply multiply it by the height. So the cross-sectional area in this instance is the base times the height. That's the other way of working it out, and it's probably a great way of remembering it like that. But again, you can use the volume, the standard volume equal to the length times the width times the height. But again, the base is 12 square meters, the same thing. 12 meters squared is our cross-sectional area. And then obviously times our height, which is 4 meters, which is 4 meters. Okay, which is equal to 12 fours of 48 cubic meters. Okay, I just thought I'd just go through that just on some prior knowledge. Now, with that being said, in terms of our surface area, let's say for example we were to dissect this or unfold this. So there's our front, and we unfold it this way. There's our sides, and we unfold it this way. So what we can actually say is, just as an example, if I were to put, let's say for example, there's my base through there, through there, and through there. Okay. There's actually, I'll just draw it a bit better. Sorry. So there's our base. Okay. And there's our side. Through there. There's our other side. Through there. There's our front, if we will call it our front. Okay. There it is there. There's the back part. I'll just draw it like this for the moment, and then I'll clean it up. Okay, and there's our top. Okay, so what we virtually have is, if I say this is 6 meters, there it is there, there's 6 meters, that's 6 meters, that's 6 meters, that's 6 meters, and that's 6 meters. Okay, if I say, let's say for example, there, just so it looks similar to the diagram for you, just for a little bit easier to show it. And then there's the top part through there, so that's the, just so it makes it a little bit more clearer for you. Okay. Just 1 second. Okay. So what we've actually got now is we're drawing this net so it looks as though we're unfolding that. Now, what we've got here now, so that's 6 meters. There's 6 meters there. There's a width of 2 meters. So we're actually starting from our base. I'll just pop that in there. Okay, just to make it a little bit more clearer. And we're saying that that's 2 meters in there. Actually, I'll do it this way. 2 meters. So that's 2 meters. That's 2 meters. That's 2 meters. Okay, then we've got our height. So our height is here, which is 4 meters. 4 meters. 4 meters. And remember, this is our top. So that's that part there, which is 2 meters. 2 meters. 2 meters. 4 meters. 4 meters. And remember, this is our height. So that's our height in there, which is also 4 meters there. 4 meters there. 4 meters there. And 4 meters there. So in other words, if I were to draw this and say, well, that's our base. That's the side, the right side if you want to call it that. This is the side. This is the other side. This is, you can call this the back. Okay, that's the top. And that's the front. It's another way of just drawing it up in that fashion there. So what we've done is we're virtually folding all this up and then folding it all over the top to resemble our rectangular prism. So in other words, in terms of finding surface area, if you find that it might be easier, you can actually say that this is 6 times 4 meters, which is 24 square meters. This is 6 times 2, which is 12 square meters. This is 4 times 2, so 4 times 2, which is equal to 8 square meters. This is also 4 times 2, which is 8 square meters. This is 6 times 4, so 6 times 4, which is 6 4 is 24, 24 square meters. And this is 6 times 2, so 6 times 2, which is equal to 12 square meters. So if you were to then add, you add that value with that value, with that value, with that value, with that value, that value, you'll find that all of those values will provide you with the surface area of this rectangular prism, just by drawing the net diagram. And a great example, this is a great typical year 7, maybe year 9, actually more year 9 measurement type a question where you would be asked to create a net diagram simply by unfolding the rectangular prism. I hope that makes great, well, I hope it helps you. I hope it provides you with a little bit of clarity. But on an exam, you would draw it like this, and it's just easier to write it up like this, the way I've done it like that. That way it's a lot easier, and you can get all the information from it, and you'll find you'll be able to answer the questions on your exam using this method. I hope that helps you, and I look forward to seeing your comments and your views, and look forward to you next time. Bye bye.